Hi, I'm Children's Librarian Kimberly Matthews of the Williamsburg County Library, and we would like to thank Mr. Ricky Powell and Andrews Fabricators of Kingstree for having us to come out and giving us a tour of the facility as well as showing us how they weld and fabricate metals. We saw sparks fly, we saw metal being cut with water, we saw the fire station that they cut metal with. It was very exciting and we really enjoyed it. Thank you once again.
Good morning. This is Bobby McCutcheon from the Williamsburg County Library. I'm here this morning with our Children's Services Librarian, Kimberly Matthews, who is holding the GoPro and she's going to video us today. And with us also is a library friend, Buddy McCutcheon, who's doing the stills for us this morning. And this fellow next to me is Mr. Ricky Powell. And he is going to tell us about his jobs at this incredible place. The name is right here. It's Andrews Fabricators. I have been interested in what fabricating is and welding is and metallurgy is for a long time. And today we're going to find out. So, Mr. Ricky, tell us what you do, what your job is.
Let's start with Ricky Powell. I'm actually HR Safety Project Manager. And what we do here is we fabricate metal, we bring in raw metals, and we basically fabricate it and kind of mold it into the structural outlets that the product, in order to basically erect metal buildings / industrial type commercial industry.
So you don't take little pieces of metal and stick them together?
No, ma'am. We have basically formed the structural metal ourselves, erected it, and it's all basically raw materials. And we actually have an engineering department that we go through on the engineering plans, and then we take it to the fab shop. We also have a cutter machine that can water jet cut, or we fire burn it and cut it. So we make cool, very patterns.
This is really, really great, but we don't know what any of this means. So can you take us and show us
Absolutely.
what this stuff means?
Absolutely.
And how people, if they're going to have a trailer or a hopper or a building, great big trailer like that one, we need somebody like you to make it for us. Is that correct?
Absolutely.
Is this something I can't make in the kitchen or in my backyard?
Absolutely. Actually, let's see if we can just start from start to finish.
Yes.
Introduce James, our engineer, and our engineering department, where they bring all the engineering plans and he gets it all together, and then it goes from there to the actual fabricators.
Great.
Sound good?
Sounds good. So step one, when you come to Andrews Fabricators, we've already done. We've met with the boss. Now we have the engineer, who's James Simmons, and he's going to tell us a little bit about how he became an engineer, where he went to school, and what he does here at Andrews Fabricators. Can you tell us a bit?
Yes, ma'am. I went through high school and had a very big interest in physics. So I decided upon going to Clemson University that I wanted to study mechanical engineering. And at that point, I was given 4.5 years of training to be able to take a basic idea and turn it from that into something that can actually be produced by our fabricators. So that process kind of goes through something like this.
Maybe we can get a look at that.
A potential client, our client will come to us with a need. In this particular case, it's a beam. There's a series of holes that mount into an assembly. They come to me with the idea or whatever's necessary, and I do 2D and 3D drawings in order to produce said part based on a certain set of requirements from the client. It's then 3D drawn, and at that point we produce a drawing that can be given to the fabricators in the shop, gives them a specific set of instructions on how to produce and fabricate the part and where that's followed through.
Now I take it when you said beam, that this thing is not a couple inches long.
No, this thing is about 25 feet long.
A big beam, and we're going to get to see that.
Yes, ma'am.
And tell us while we're at your desk, What's this? What's that instrument you're using? What do you
I have
use
a
that
set
for?
of dial calipers. I am actually doing some quality control to see that this part was actually produced by a machinist as per the specification by the client. I'm going to verify. We know that this one works, but it doesn't necessarily match a set of drawings that was done 15 years ago. So I'm updating the drawings so they can be produced as it is needed now.
So I take it being an engineer is a really important job.
Sometimes.
Sometimes. And is it fun? Do you love it?
I absolutely love it.
So what you learned in school, you're applying every day to a product your company is making.
Yes, ma'am.
So that's pretty exciting.
It is.
Well, you're wonderful to meet with us and tell us a little bit about. Now, you lost me at the first point. What's physics?
Physics is a series of laws and mathematical rules that we live by every day. You just don't realize it.
Like what?
The fact that you have to use a force in order to stand up.
Ooh, you didn't know that.
Yes. And there's always an equal and opposite reaction, so we use that in our designs to make sure that it can withstand whatever forces are required.
James, you're wonderful. You're just full of information that we need. And it's such fun to see you. And now we're going to go see what you're making.
Yes, ma'am.
All right. Thank you, James.
Thank you.
Okay, we are in what Mr. Powell has described as a machine shop. It has all kinds of things I've never seen before. And maybe he could tell us real quickly, what do you do in here before we go into the most fabulous place ever, the fabrication area?
What's in here? We have lathes, we have our drill presses, and basically what we do here is we take and we basically cut down the instance something as small as this. We can take and put it in our lathe and just twirl it and all the way grind it to fab.
This is a lathe?
No, ma'am. This is the lathe.
That's the
This is
lathe.
handle.
Wow.
That's the lathe. That's the drill press. And basically, what we can do is put it in here and then just take an ordinary piece of metal and mold it to fit or fab any structural or individual.
So a person like me
Yes, ma'am.
can't touch this thing.
No, ma'am.
So you would have to have some kind of training to be allowed to touch this thing.
Absolutely.
And where do you get training for that?
We have in-house training that we run through. We have structural diagrams that they have, and also they have online classes that they actually go through.
Now, a person running this, would they need safety glasses?
Absolutely.
So they don't have pieces of metal in their
Absolutely.
eye.
Safety glasses, gloves as well, and we also require this necessity steel toe shoes.
Oh. Yep.
Steel toe
Yep.
shoes.
He's wearing them steel toe shoes. And
Proper
that,
PPE. Proper PPE is
what
what
is
it's called.
PPE?
Personal protection equipment.
And a steel toe
Steel
boot
toe
or
shoes.
shoe
Yes, ma'am.
has steel up here,
Yes, ma'am.
inside there.
Absolutely.
So if something heavy were to fall on your toe, it wouldn't hurt you?
Absolutely.
Okay, well next time we'll bring our PPE. You'll let us do more, right?
As we progress through this, you also see that PPE is required. You'll see the guys with safety glasses. If they grind, they have shields on, proper gloves, and of course shoes.
Okay. Now, Mr. Powell has guaranteed we're going into the most fabulous place ever, which is either that way or that way. I think it's that way.
Where we actually going right at this moment, we're heading to what we call a phenomenal, phenomenon. I'll get to it in a minute. An awesome, let's go awesome.
Awesome. Okay, we know that word.
Where are we going now? We're going to an awesome area where we're going to take, and we have a water jet table and a burn table, where we get the prints from James, and it goes. This is just a section. If anything needs to be designed, it goes to our design guide where he's going to take and cut it out in water jet or air jet.
So this is like Disney World for people like us
Absolutely.
who love stuff like this.
Absolutely.
I can't wait.
We could do Gamecock, we could do Clemson, we could do Williamsburg Technical College, we could do Williamsburg library, we can do anything.
Wow. Let's go look.
Okay, let's
All
go.
right. All right, we are now with John Britton, and he's going to show us what he's doing back here, and he's wearing the coolest hat I've ever seen, or one of them. Look at that. And it tells us a little bit about where we are. All right, what do you have here in your hands?
Pretty much what we do is, like y'all talked with James about it, and this will be kind of like a print that he draws, and I basically take it from there, put it in the computer, and then put it in the machine to program to cut what he wants cut out of all the raw material.
Now, when you got out of kindergarten, did you know how to do this?
No, ma'am.
So how did you, like I'm in 2nd grade, tell me how your life went so you got to do this.
Well, when I graduated from high school, then I went to college for it, did 2.5 years of college for it, and then ended up here.
That's great. Are you going to show us what happens next?
I can, yes, ma'am.
Okay, you want to come with us?
This machine basically does identical to what the water jet does, it's just in a different format. As you can see, the slag and everything is kind of left on the aftermath of it.
So how does this work?
This runs off basically torch, like a cutting torch.
Right.
It's basically what they do, it runs off of gas, refrigerant, and it comes through here. It's like the same as he's going to show you on the water jet. He'll lay a piece of metal on here, and it's all programmed on the computer, and then it'll cut out any sort of type of design that you would like.
So his computer sends a message here,
Yes, ma'am.
and it controls what the design this cuts out on a piece of metal that is here.
Absolutely, yes ma'am.
Wow. So you don't have to stand here with your torch and try and do this.
Absolutely.
Wow, that's incredible. I had no idea.
It's like the old method of using the hand torch is obsolete these days.
Right. So you could do, theoretically, a sign that's that big,
Absolutely.
cut
yes, ma'am.
out that says, Ricky Powell is a super nice guy.
Oh, cool.
To let us
I love
in,
that.
right?
I love that part. Yeah, absolutely. I love that
Okay,
part.
that's great.
Absolutely. But yeah, and it's kind of like I was looking around to see if we had any here, but we actually do have some on the wall in the office, and we've cut out the Carolina Gamecock emblem. We've cut out Clemson, and as we go into the fab shop, we can see we have a few cookers.
Oh, nice.
We also fab cookers, and we've had requests to put the company's name in them, engrave them, and all kind of
Sure.
it's all kind of phenomenal stuff. But like I said, we take and we just burn designs. You can cut designs in it, and this is just a different method. It is a little quicker than the water jet, and it's a little bit more precise.
Now you mentioned slag. The slag is what? This stuff.
Yes, ma'am.
But how does- what is that?
debris, this is the slag. It's very, all that is just melted metal.
It comes out of the piece you were
Yes, ma'am. Yes, ma'am.
cutting out.
Yes, ma'am. The design and everything, if we laid out just a flat piece of metal, and he had take this, a seat, he would cut out the seat, and all the slag goes right on these plates right here.
Now, I guess every once in a while you have to get that slag off.
Absolutely. Basically, what we do is we take and pull these plates out, and we just interchange the plates.
Oh, so you remove the whole plate
Yes, ma'am.
and you don't clean these off, you have to use a new
Well,
plate?
with all that slag and everything in that, it's very difficult because all that is kind of formed together and melted.
Right.
So we basically just take it and place these at a certain little cost, of course.
Right, and what do you call this?
These are our fins.
Fins?
Yes, ma'am, the fins. Those are the fins we have.
This is wonderful.
And it's basically a grate, I call it grate fins. Grate fins, like a grate.
Right.
And basically,
G-R-A-T-E.
yes, ma'am. Yes, ma'am. And we just take them, like I said, all we do is just snap them up and replace them.
This
Because
is-
as you can see, the more detail it goes, it kind of deteriorates and takes away from the original plate.
I see.
If you can see right here as it's going down, it basically cuts down into that plate.
It looks as though this machine
Yes, ma'am.
will last a long time.
Absolutely.
You don't
Absolutely.
replace these every month.
No, ma'am, they're too expensive.
Right. But they're heavy duty and they're meant to
Oh, absolutely.
last.
Basically on the machine itself, as long as you do preventive maintenance on it. We have actually an outfit that comes in and they basically do preventive maintenance on it. They'll go through it from one end to the other. Our most point would be our burn area. Most point of contact, yes ma'am, that's this part here.
Oh, okay.
And that, if you look right here, the old-timey torch, that kind of looks like an old-timey torch. And it goes through here in gas and it comes through as right here is just like fire.
So when this thing is running, is anybody in the room with it?
Mostly, a few times he may come in here just to spot check, but mostly no one's in here.
Yeah.
As I said, John may come in here and just kind of sporadically look, but normally no one's in here. And these doors are, they're open
Okay.
to help.
These,
Yes
yeah,
ma'am,
to
these
ventilate.
roll-up doors are open to help with ventilation. We also have a big fan,
up there.
yes ma'am, that pulls these vapors up.
Right.
So that's, as far as safety-wise, you have to also encounter your vapors and everything enclosed. That's why we have to have these roll-up doors and access to pull it out,
Right, absolutely.
to extract it.
So there are a lot of elements in making a metal sign.
Yes, ma'am.
Yes.
And a good start would be just like James. He gives us the design. John can take it, and then he goes into his computer, so he's getting ready to cut it out. Then we go from that to the fab to where it actually fab it all in.
Now, is John the one that does all the cutting on these?
John is the one that does all the cutting.
Okay, and so his title would be?
John's is production manager over the cutting.
That told this machine to make something cut out like this,
Yes, ma'am.
and then it came in and pushed a button that said do it now?
We'll just load the program into the machine, yes, ma'am, and change settings and all depending on different materials.
That's
Yes, ma'am.
really phenomenal. Do you know how many pounds per square inch or whatever?
Well, it's actually 60,000 PSI, or sometimes they measure it in bar.
PSI is pounds per square inch.
Yes, ma'am.
This is amazing. Is this hot?
No.
Oh no, because it's been in the water. And it's so smooth. Look at that cut. Wow.
So what's the thickness?
We can cut up to 6 inches, but we cut 4 inches before. But it just slows down the thicker it gets. Just takes
Sure.
more time.
Right. You're going to have all kind of groupies.
I doubt it.
The water cutting groupie person. This is great. Thank you, John. This
Yes,
is
ma'am.
wonderful.
Thank y'all.
We were promised really stuff back here without it.
Well, hopefully we provide it for you.
Thank you.
it's got a gap in it now.
Look here, you see what I'm talking about as far as being
Oh, right,
level?
yes.
Level.
I got
What
you.
happens is they'll
How did they
grind off.
Did they grind? That big plate that you have it on the ground.
It's gonna be a tank. It's gonna be 14 foot round, 24 foot tall. It'll be stacked, 5 stacks on it. Plate. See that flat plate laying in there? All that's gonna be rolled and made a round tank out of it.
Oh, I see. Okay, so the next thing you do is weld it together.
Put it together, then we have to roll all that plate, and then we stack it on top of one another. 24 foot tall, be 14 foot round.
Wow. Well, Randy, thank you for letting us watch what you do. I really appreciate it for letting us come.
I'll give it Ricky. We'll take a picture when it's done and send it to you.
Oh, thank you. That'd be great.
Hi, we would like to thank Mr. Ricky Powell and Andrews Fabricators in Kingstree. Thank you, thank you, thank you.